So let's try some continuity questions. Number one, this looks like a nice rational function, and we have a hole here, but we have a dot that's filled in here. Where is this function f continuous? Well, there's some discontinuity right here. So it's continuous everywhere for all real numbers except for here, which is called a hole or a point discontinuity. And then here we're jumping from positive infinity to negative infinity. So there's a discontinuity here as well. We'll call this a infinite discontinuity. Number two. Now this function here, sine 1 over x, this actually appears to be solid, but it's oscillating so quickly towards the middle that we're so confused as to what the actual y value is. Is it positive 1, negative 1, 0, or somewhere in between? So we're going to call this oscillating discontinuity. So it's not continuous. The range, interestingly, is between negative 1 and 1, because sine of anything, it must be between negative 1 and 1. Finally, is this function continuous? We have a hole that's filled in here, so this looks like a piecewise function. This looks like absolute value of x over x if x does not equal to 0, but the function happens to be 0 if x equals 0. So this is a piecewise function here. This is f of x. So this is f. It's a collection of all this information here. And as you can see, when you take a solid line and you draw it across, if you have to lift your pencil, it's not continuous. So we're going to say it's continuous everywhere, but not at x equals 0.